It is the oldest human ritual. Before iPhones, before language, before we had names for fire or fear, we had this, the sky. A black velvet cloth pricked with a billion needles of light. We call them stars, but to our ancestors, they were something else entirely. They were campfires in the sky, ancestors watching, gods arguing. And among those thousands of distant suns, a few have always stood out. The brightest ones. The ones that cast shadows on the ground. The ones you see even through the haze of a city. But here is the secret that the astronomers keep. When you look at them, you are not really looking at stars. You are looking at a time machine. You are looking at violence. You are looking at ghosts. This is the true story of an epic journey. Not a journey of miles, but of light. Across the impossible dark to the brightest stars in our sky.
If you live on Earth, there is a king. You might not know its name, but you've bowed to it. Every winter, just after the new year, step outside before dawn. Look southeast. You will see it. Flashing. Blue-white. So bright it seems to have a pulse. The ancient Greeks called it the Scorcher. We call it Sirius. But the true story of Sirius begins not in Greece, but in the mud of the Nile. 3,000 years before the birth of Christ, the priests of Egypt noticed something terrifying and wonderful. For most of the year, Sirius vanished into the glare of the sun. Then, one morning in July, poof, it would reappear just before sunrise. They called it the Heliacal Rising. And here is the cosmic coincidence that built a civilization. The moment Sirius returned, the Nile began to flood. The star, Sothis, as they called it, became the clock of the gods. They built their calendar around it. They carved it into the lintels of their temples. Because Sirius was not just a light, it was a promise.
But here is the physics lesson hidden in the myth. Why is Sirius so bright? Is it the biggest? No, absolutely not. Let's look at the engineering. Sirius is a twin, a binary star, 8.6 light-years away. The main star, Sirius A, is a blue-white jewel. It is 25 times brighter than our own sun. But it is its companion that tells the real story. You see, in 1844, the German astronomer Friedrich Bessel noticed that Sirius was wobbling like a drunk leaving a bar. The math said there had to be something there, pulling on it. When they finally pointed the telescope, they found a monster, a dead star, a white dwarf, Sirius B. An entire star, as much mass as our sun, crushed into a ball the size of the Earth. A teaspoon of Sirius B weighs 5 tons. Think about that. The brightest star in our sky is being orbited by a corpse, a burned-out cinder of gravity so intense that time itself slows down near its surface. So, when you look at Sirius, you aren't just looking at a light bulb. You are looking at the cycle of life, the living star and the ghost of a star, dancing a waltz that takes 50 years to complete.
But if Sirius is the king, then Canopus is the emperor in exile. If you live in New York or London, you have never seen the second brightest star in the sky. You have to go south, way south. You have to stand under the tail of the constellation Carina, the keel. The name Canopus sounds Greek, but it holds a secret. After the Trojan War, King Menelaus was stranded in Egypt. His navigator, a pilot named Canopus, died on the sand. The king looked up, saw this blazing star, and named it in his honor. But the true story of Canopus isn't about war. It is about distance. Look at the specs. Canopus is a supergiant. It is 65 times the size of our sun.
It burns at 13,000 degrees. And here's the kicker. If you put Canopus next to Sirius, Canopus would eat it for lunch. It is 10,000 times brighter than our sun. So why does Sirius look brighter? Because the universe is a thief. It steals light. Sirius is only 8 light years away. It's the neighbor waving from across the street. Canopus is 310 light years away. It is a lighthouse on the other side of the ocean.
This distance made Canopus the hero of the human race. When NASA built the Voyager spacecraft, those little golden records we threw into the abyss, they needed guide stars. Floating through the black, how do you know where you are? They used pulsars. And they used Canopus. Canopus is the lighthouse. It is so steady, so bright, that even when you are billions of miles from home, lost in the dark between the planets, you can look for that one point of light in the southern sky and say, I am here. The Egyptians called it the Golden Star of the South. The Chinese called it the Old Man of the South Pole, a symbol of longevity. It watched over the pharaohs. It guided the Polynesian canoes. And right now, as you sit listening to this, it is watching over the vacuum of space, where no human hand has touched. We have looked at the king and the giant. Now, we look for hope. The third brightest star in the night sky isn't actually a star. It's a system, Alpha Centauri.
When you see it, you are looking over the fence into the neighbor's yard. 4.27 light years. That is the distance. On the scale of the galaxy, that is close enough to smell their barbecue. But here is the tragedy of Alpha Centauri. To the naked eye, it looks like one star, the third brightest. But through the eyepiece of a telescope, it shatters into two. A golden sun, A, and an orange sun, B. For centuries, astronomers measured it. They watched it wobble. In 1834, they started mapping its orbit. They realized they were watching a binary. Two massive objects dancing around each other, locked in a gravitational embrace that takes 80 years to complete. But the epic part of this story happened recently, in 2016. Hiding next to these two giants is a dim little runt, a red dwarf we call Proxima Centauri. It is so faint you can barely see it with a large telescope. But it is the most important star in the sky, because Proxima Centauri is the closest, 4.24 light years away.
And in 2016, the European Southern Observatory announced a discovery that changed the definition of the brightest star. They found a planet, Proxima b, a world orbiting that dim red sun. It is roughly the size of Earth, and it sits in the Goldilocks zone, not too hot, not too cold. For the first time in human history, we found a place out there that might have water, that might have air. The brightest stars used to be the ones that shined the hardest. Now, the brightest star is the one that offers a place to land. We shift gears now, from the distant neighbors to the time travelers. Let's go to Chicago. The year is 1933. The Great Depression is strangling the world. But there is a World's Fair, the century of progress. The scientists wanted to do something magical. They wanted to turn on the lights of the fair with starlight. They pointed a telescope at a giant orange star named Arcturus, the fourth brightest in the sky. Arcturus is a massive red giant. It is old. It is tired. It has run out of hydrogen and is now burning helium, puffing up to a size that would swallow Mercury if it were in our solar system.
But here is the trick. In 1893, Chicago held the world's Columbian Exposition. 40 years earlier. The astronomers calculated the distance to Arcturus as roughly 40 light-years. Do the math. The light leaving Arcturus in 1893 arrived in Chicago in 1933. They hooked the telescope to a photoelectric cell, a magic eye. When the light from Arcturus hit that cell, it generated a current. That current flipped a switch, and the lights of the century of progress exploded into the night. The light from the past turned on the present. But let's not forget Vega. Vega is the 5th brightest star. It hangs overhead in the summer. Blue, white, gorgeous. Vega is the queen of firsts. It was the first star to have its photograph taken, the first star to have its spectrum recorded. It is the benchmark of the sky. But here is the eerie thing about Vega. 14,000 years ago, Vega was the North Star. Our ancestors looked up, and the sky spun around this blue diamond. In another 12,000 years, it will be the North Star again. The pharaohs are gone. The empires are dust. But Vega just spins. It just burns. It is the clock that ticks for 25 million years. We cannot talk about the brightest stars without talking about death. Look at the constellation of Orion, the hunter. 2 shoulders, 2 legs. The left foot is Rigel. The right shoulder is Betelgeuse. These are not stars. These are bombs waiting to go off. Let's start with Rigel, the 7th brightest star in the sky. Rigel is a blue supergiant. It is 70 times the radius of the sun. It burns at 11,000 degrees on the surface. If Rigel were as close to us as Sirius, it would cast shadows so sharp you could read a book by its light at midnight. It is 40,000 times more powerful than our sun. But Rigel is far, 860 light-years away. It sits in the Orion Nebula, cooking the gas clouds around it. It is a star so violent that its wind blows at millions of miles per hour. But Betelgeuse is the ticking bomb. In 2019, Betelgeuse did something terrifying. It dimmed. Astronomers held their breath. They thought, is this it? Is the supernova finally here? Betelgeuse is a red supergiant. It is so big that if you put it where our sun is, its surface would extend past the orbit of Mars. It would swallow Earth whole. It is 642 light-years away, but it is unstable. It is fusing heavier and heavier elements in its core, carbon, neon, oxygen, trying to fight off gravity. And eventually, it will run out of fuel. When Betelgeuse dies, for a few weeks, it will outshine the full moon. It will be visible during the day. It will be the brightest star in the sky by a factor of 1,000. Then, it will fade. Gone. But here is the miracle of the true story. That explosion, a supernova, is not an ending. It is a beginning. To truly understand brightness, we have to look at the brightest event. The year is 1006 AD, May 1st. Monks in Switzerland, scribes in Egypt, astronomers in China and Japan. They all recorded the same thing. A new star appeared in the constellation Lupus. It was so bright it cast shadows on the ground. They called it a guest star. Modern astronomers found its ghost. Using radio telescopes, they mapped the wreckage. It was a Type 1a supernova, the complete destruction of a white dwarf. This explosion was 100 times brighter than Sirius. It was 50 billion times brighter than the sun. That light took 7,100 years to reach Earth. When it arrived, it blinded the medieval world. But the same physics that destroyed that star created the calcium in your bones,
the iron in your blood. Look at the Crab Nebula, another ghost. Chinese astronomers recorded that explosion in 1054. They saw a guest star in Taurus. Now, when we look at the Crab Nebula, we see a pulsar, a neutron star spinning 30 times a second.
That star isn't burning. It's a magnet the size of a city, spinning at the speed of a blender, shooting beams of radiation into the void. Those are the brightest stars, the ones that are no longer there. We have traveled across 7,000 years of light. We have looked at the dog star, the navigator, the bomb, and the ghost. But here is the truth, the real truth. The brightest star in the sky is the one you are standing on. We get so obsessed with the distant suns, Sirius, Canopus, Betelgeuse, that we forget our own star. If you hold a mirror up to a distant star, you won't see your face. But if you look at our sun, it is blinding. We are made of the dust of those dead stars. The iron in your blood is the last gasp of a supernova. The calcium in your teeth is the ash of a giant. Every atom heavier than hydrogen and helium was forged in the belly of a star that exploded long before the Earth existed. When you look at Sirius, you are looking at the furnace. When you look at Betelgeuse, you are looking at a mirror of our own future. When you look at the darkness between them, you are looking at the debris of the ancestors. We are not just looking at the brightest stars in the sky. We are returning to them. The epic journey ends where it began. You, standing on the grass, neck craned, eyes wide. The ancient Greeks had a word, eudaimonia. It doesn't just mean happiness. It means being seen by a good spirit. When you look up tonight, understand that the light hitting your retina left those stars before Rome fell, before the pyramids rose, before humans learned to write. And yet, it arrived now, just in time for you to see it. The universe is not cold. It is just traveling. And tonight, for this brief moment, the light of the giants, the dog star, the red giant, the blue supergiant, ends its billions of miles journey on the back of your eye. Look up.